Hey chemists, today we're going to be talking about the physical and chemical changes lab. So in this lab, we're looking to observe the differences between physical and chemical changes. Well, what is a change? Why do we talk about change in chemistry? Well, chemistry is literally the study of change. Now, you've all heard that it's the study of matter, the study of what stuff is made of, and that's true. But it's also the study of how those things can change, how matter can change into new things. So when we're talking about the study of change, chemistry, we need to talk about the different kinds of changes that there are. So we've probably already talked about physical versus chemical changes a little bit. But in this section, we're really going to be delving deep into what the difference is between them. With a physical change, you're changing something's physical properties. You might be making it bigger or smaller, or changing its color, or mixing two things together. But in a chemical change, you're actually creating something new. Now we know that because of the law of conservation of mass and matter, we can't actually create atoms from nothing. But a chemical change is talking about rearranging the atoms in something. You're creating a new substance by taking those atoms, taking those elements that you had before, and rearranging them to form something new. So we're going to go through a couple pre-lab questions here to kickstart your thinking about what is a physical versus a chemical change. How can I tell the difference and tell them apart in the experiments that we do in the lab today? So the first change that we're talking about in our pre-lab questions is burning wood. I want you to take a look at this image of wood burning here and think to yourself, do I see something new? Is there something new being formed here? Or is it all the same stuff that I saw before? Next, we have dry ice changing into gas. Now, dry ice, if you didn't know, is solid carbon dioxide. So it's starting as carbon dioxide and changing into a gas. Is that carbon dioxide that's coming off of it, that fog, that gas that you see there, is that something new that we're forming? Or is it the same substance that we had before? If it's the same substance that we had before, then that's got to be a physical change. Remember that phase changes from something like a solid to a liquid, or in this case a solid to a gas, which we call sublimation. Phase changes are always physical. All right, next we're going to see this image of water freezing, right? Again, think to yourself, if water becomes ice, is that something new? Or is that the same chemical substance? Is that ice still H2O at the end of the day? It is. So if it's still H2O, is that something new? No. So that's got to be a physical change, right? All right, next we have a picture of ripening fruit. Is there something new there? Do we see something new that we didn't see before? Did it change to a new color, proving that there was some sort of new chemical substance there? I know it's still fruit, but is there a new chemical there that we couldn't see before? And lastly, we have some sugar dissolving in water. So look at this. The sugar dissolves in the water. We talked about dissolving. When something dissolves, it seems to disappear, seems to be absorbed into the solvent, into the liquid water. But think to yourself, is there something new there? No, we can't see the sugar anymore, but I don't see anything new. I still have sugar and water. And if you tasted that sugar water, it would still have the properties of both. It would still be a liquid and still taste sweet like sugar. So is that anything new? Not really. So dissolving something is always a physical change. So I know that we've talked about this one before. Remember that we have 5 observable signs, things that we can see or detect with our senses, that show that a chemical reaction is taking place. Let's think through some of them, and which ones we might have seen in our previous changes that we just talked about. So number one is if you see an unexpected color change. So not mixing blue and yellow to make green. Everybody knows from art class that those two colors mix to make that color. But if you see something unexpected, if you see an apple change from red to brown to black as it rots, That's unexpected, right? Sure, you might expect it from your previous experience, but normally something red doesn't just change into something brown and then into something black. That's an unexpected color change. Let's think about the wood, right? Wood changed from that brown wooden color to black charcoal and then white ash. That's evidence that there's something new there, a new chemical that has a different color. Number two is if we see some gas or some bubbles coming off. So with the wood, you definitely saw smoke of some sort, right? It's evidence that there's something new there, a gas being produced. Today you might see bubbles in a liquid, right? Bubbles are evidence that there's gas in that liquid, and that liquid is trapping that gas in there. It's evidence that there's something new being created. Now, we have to be careful with this one because boiling a liquid causes it to change into a gas. That's not something new. It's the same substance, just in a gas phase. So boiling is not a chemical change. Don't be deceived by that. If there's a new gas, that's a chemical change. Number three is if you see a precipitate form. Remember, we saw this a couple weeks ago when we did the writing ionic formulas lab. We mixed two substances together, two liquids, two aqueous solutions. And when they mixed, they formed a solid. That solid is something new. That's a new chemical that we didn't see before. Now, it's made of all the elements we already had, but it's a new substance because those elements have been rearranged to make something new. Number four is the evolution of heat or light, the release of energy. So if we feel something getting hotter and we didn't add heat to it, that's definitely a chemical reaction. That's what we call an exothermic reaction. It produces heat all on its own. We also have endothermic reactions, which become cold as they progress. So we might see one of those sometime. An endothermic reaction makes the substance colder because it's absorbing heat from its surroundings. And the last sign we have a chemical change, number 5, is an odor or smell. So if you detect an odor or smell, that means there are new molecules being formed that you can detect with your nose. So if there's something new, it's got to be a chemical change. So these are all signs or indications that a chemical change is going on because they're all pointing to evidence that something new has been created. Remember, if you see something new, it's a chemical change. Okay, so let's get into some of our changes here. Remember, for each change that you're looking at today, think, is there something new? Did the identity of my substance actually change? If yes, then you have a chemical change. If no, if it's still all the same substances that you started with, it's a physical change. So let's look at number 1 here with our paper. Okay, so for experiment number 1, I have an ordinary piece of newspaper here. So what I'm going to be doing is making 2 changes to this newspaper. In the first one, I'm going to take this paper and tear it up into tiny pieces. So when I do this, as I tear this paper up, am I changing the identity of that paper? Is it still newspaper? It's clearly different, right? It's clearly in much smaller pieces and in a different shape. So it's a change. But is there something new here? If not, it's a physical change. If yes, if you think there's something new, then we'd call that a chemical change. Okay, so I have my newspaper here now. It's been torn up into little pieces. Okay, so now that I have my paper all torn up here, I'm going to place it on that watch glass and ignite it with a match. And we're going to see what kind of change that is. We're going to see if we can tell if it's a chemical change or not. Remember, we're looking for heat or light, something new to be created, a new, different looking substance. So let's check it out. So what do you think? Do you see heat or light? Or maybe a gas being produced? Does the newspaper look like it did before? Or does it have a new color? I'll tell you, I definitely smell something. So what do you think? If I have all these signs that I can observe, is this a physical change or a chemical change? Okay, for experiment number 2, I'm going to be taking some water, good old H2O, and some table salt, NaCl, and mixing them together and seeing what happens. So I'm going to measure out about 5 milliliters of water in my graduated cylinder. So measure that out. I got about 6 milliliters there, but that's okay. I'm going to measure that out, pour it into a test tube. Now I'm going to take a micro spatula full of this table salt, NaCl, and I'm going to add that into my test tube and mix it in there. So this is what the salt looks like to start. I'm going to mix it into the water and see what kind of change I have. I'm going to put it in there. I'm going to mix this around a little bit. Give it a couple good shakes, kind of get that salt down in there. Okay, so there's definitely some sort of change because for the most part, I don't really see that salt anymore. I don't see any more white crystals there. But the real question is there something new here? Do I see a new substance? Do I see a really unexpected color change? Do I see gas being produced or a precipitate being formed? Or did that salt just seem to dissolve, disappear? Is that something new? Or do I still have salt and water, just one dissolved in the other? Okay, so now I'm going to take this salt, this NaCl, which is now in an aqueous form, dissolved in water, and I'm going to add another chemical, which is silver nitrate, AgNO3. So I'm going to add this silver nitrate into this test tube, and I'm going to look again to see if there's a change. So I'm going to look to see if I see an unexpected color change or the formation of a precipitate. So I definitely saw a color change there. One that I definitely did not expect. And it looks like it's a little bit cloudy, right? Like there's something chunky inside that solution. Is that evidence that there's something new there? What do we call that when we mix two liquids together that form a solid? It looks kind of like it's snowing. What is snow and rain a form of? It's called precipitation, right? So did we form precipitate here? What kind of change does that make this? Okay, for my next experiment here, I've got a shiny piece of magnesium ribbon. So we've used this magnesium ribbon before. We lit it on fire and saw that it produced magnesium oxide and a chemical change where it produced something new and produced a lot of heat and light. So today we're going to take this magnesium ribbon and we're going to cut it up into pieces, right? I'm going to take this magnesium ribbon and just cut it into small pieces here. Pieces that are flying everywhere. Okay, so I've got my pieces of magnesium ribbon here all collected. So tell me, they definitely changed. It's not a long ribbon anymore. But is there anything new there? Did my substance actually change its identity or change into something new? Okay, so now I've got my pieces of magnesium ribbon inside this test tube here. And because I'm about to work with a strong acid, with some 6 molar hydrochloric acid, which is a very strong acid, because I'm working with that, I have put on my nitrile gloves, very fashionable, very chic, and I'm going to use them to add this acid to this magnesium here. So when I do this, watch to see if you observe any evidence of a chemical change. Do you see something new here? Okay, definitely something new. I don't remember there being bubbles there before. So if that's the case, what kind of change do I have here? If I feel the outside of this test tube, whew, it's pretty hot. What else does that tell you? What was released when I added the hydrochloric acid to the magnesium? Okay, for my next experiment here, number 4, I have some classic chemicals. So I've got vinegar, also known as acetic acid, which is a weak acid. We've also got baking soda, which you should remember is a base. So acids and bases, both potentially harmful. In this case, they're both okay. But they're also opposites of each other. And so when you mix them, we're going to see them react. All right. So I'm going to put 10 milliliters of this vinegar inside the graduated cylinder to measure it out. Got about 10 milliliters there. And I'm going to add this to my itty bitty 50 milliliter Erlenmeyer flask. Okay. Now I'm going to take my baking soda, my sodium bicarbonate, and add just a small amount to this flask. So I'm going to take a tiny micro spatula and add some baking soda inside. And when I do that, I'm going to immediately put a cork on and see if I observe any changes. Okay, so what happened to the cork when I put it in the Erlenmeyer flask and shook up the mixture there? It popped off, right? Why would it pop off? What was I producing there when those two substances reacted together that built up pressure that caused that cork to pop off? Is that something new? Did I have a gas building up pressure before, or is that gas, those bubbles, evidence of something new, of a chemical change? Okay, for my next experiment here, I've got 2 more chemicals. The first one is called hydrogen peroxide. Its chemical formula is H2O2. Now you might recognize hydrogen peroxide. That's the stuff they sell in a brown bottle in the pharmacy that maybe your mom or dad put on your cut when you got scraped up as a kid. It's used as an antiseptic, which means it's good for cleaning out wounds because it creates oxygen gas and water, which are pretty good at oxygenating and cleaning out wounds. It's also one of the common ingredients used in what we call elephant toothpaste. So if you've ever seen a demonstration with elephant toothpaste, that's the decomposition of hydrogen peroxide, H2O2. So I've got 15 milliliters of hydrogen peroxide in this flask here, and I'm going to add a second chemical, which we call manganese dioxide, which is MnO2. So this manganese dioxide, it's kind of a gray, dark gray, blackish powder, right? So we're going to add a little bit of that to the hydrogen peroxide. We're going to see what happens. We're going to see what kind of change we observe here. There she blows. So that might look kind of similar to an experiment that we've done before, that we've seen in our Halloween demonstrations, that we called the genie in a bottle, right? This was the same reaction, actually, taking hydrogen peroxide and breaking it down with a catalyst of manganese dioxide. So, did you see something new there? I think we did. We definitely saw some new gases, some new substances there. If I touch the bottle, it's definitely warm. It's an exothermic reaction that gave off heat. So what kind of change does that have to be? So for our last experiment here, experiment number 6, I have a chemical called tert-butyl alcohol, called TBA. Now, this is definitely a chemical. And anytime that I start off with a chemical substance that has a fancy name, I'm thinking, boy, I'm going to see a chemical reaction or a chemical change. But go ahead and observe this TBA, this tert-butyl alcohol here. What does it look like? Looks kind of solid and chunky, frozen. Looks kind of like ice, right? What we're going to do here is we're going to hold the bottom of this test tube. We're going to hang on to this TBA here and see what happens to it over time. So I'm going to hold it and show you what's happening to it over time. So what seems to be happening to this tert-butyl alcohol, this TBA, over time? I definitely haven't put anything inside of this tube, so it's all the same stuff. But it appears to have gone from a solid substance to what looks like a liquid. What do we call that when ice goes from being a solid to being a liquid? That's called melting, right? So this TBA here appears to be melting. Now that's a phase change. And also, do we see anything new there? Is there a new substance? Did the identity of this TBA change? Or is it still the same substance, just in a new phase, a liquid phase? What do you think? And if we look finally at this TBA here, the tert-butyl alcohol, it's now completely liquid. Again, is it still the same substance? Is it still TBA? I'm going to classify that as a physical or chemical change and support your answers with evidence. Okay, so we just saw a bunch of different kinds of changes. It was pretty obvious that there was something new created there. Maybe there was a gas or bubbles or a precipitate forming. Maybe there was an unexpected color change, or there was a lot of heat and light produced. All of those are pretty good signs that we have evidence of a chemical reaction, and if it's a chemical reaction, then it's a chemical change. So this has been the Physical and Chemical Changes Lab. I've been Mr. Adam. Thank you very much for watching, and we'll see you on the next one. Good luck on your lab, chemists.